A big part of the mission of the International Space Station is to get humans ready to explore beyond low Earth orbit and out into the cosmos. When that happens, those future explorers and their support teams on Earth will have a communication issue to deal with because of the great distances between Earth and Mars, or to an asteroid. Communications won't be instantaneous as they are now. They'll have a delay of seconds or even several minutes before the signal is sent from Earth, reaches its destination, then those signals have to come back. NASA teams have been working on this issue, and one of the proposed solutions is being tested on the space station this week. NASA commentator Lori Meggs is at the Payload Operations Integration Center in Huntsville, Alabama, where they are closely monitoring these operations. Lori.
Autonomous Mission Operations Express 2.0 is currently being tested on the space station. Angie Haddock is the lead for the AMO operations here at Marshall. And Angie, first of all, let's talk about how we're using the space station to test communications between Earth and Mars.
One of the tests that we can do is have the astronauts be able to manage ISS hardware like Express Rack that is on orbit currently.
So what is an Express Rack?
An Express Rack is a rack that's on orbit that houses the payloads, and the Express Rack provides the power, data, and thermal for Express Rack operations.
So going back to the testing, just how long does it take to send a signal from Earth to Mars?
If Earth and Mars are currently lined up and as close as they are today, it's about 2.5 minutes, but it could be up to 24 minutes if they're not as close as they are today. So that can make communications between the spacecraft and the crew and the ground very difficult.
It's a pretty long time.
Yes, it is.
So you guys are looking at forward-thinking concepts.
Yes, we are. We're looking at things that can help the crew and or spacecraft be able to operate without as much ground control as we have today.
So the delay that we're talking about is relevant for just more than just voice communications.
Yes, it is. It's not just voice. We have data and also file transfers, so that if we were to have a communication going along with the crew that was in deep space, and there was a long period of time, like 24 minutes, then by the time that we got the information and be able to turn around to do like a ground commanding, it would be another 24 minutes. So there's a lot of things that could happen within a half an hour.
You guys are looking to fix that. Tell me about some of the previous work we've done to look at these communications issues.
Yes, some of the things that we've done here on the ground is that we've had like doing robotic things out in the Arizona desert, as well as having the aquanauts live in underwater habitats. But those things they're not high fidelity. They don't have like the space hardware, so we're trying to use the International Space Station to get better fidelity.
So what types of things are the crew commanding? I mean, what do they command? It's just a single button, right?
Yes, that we have tried to automate, where it's just like everything is automated for the crew, for them to be able to use in deep space missions.
So they can do their own activities?
They could plan their own activities. They could operate, like say payload racks. They could operate medical devices, things that now they rely upon the ground controllers to do.
So AMO Express 2.0, I love that name, is the next step. What is the plan for this experiment?
Well, within the past 2 weeks, we had the ISS crew to execute AMO Express 2, and they've been able to activate and deactivate Express Rack 7 on orbit, and they've done it via the Timeliner automated procedures, and those will resided via an application that was on one of the laptops that was on orbit. So they were able just to do just a single button function, and it executed like all of the commanding for deactivation and activation of Express Rack. And in today, normally the pro here at Marshall, they're the ones who do the activation and deactivation of the rack, but there's also a lot of synchronization between Marshall and Houston, so that they can, because some of the things that Houston are like the power and the thermal that they're controlled over, but we were able to put all of those, the core and the commanding, all together into a automated procedure, and so the crew was able just to use one button function.
I'm sure they like having that control.
Yes,
if they think
do.
of it.
They like it a whole lot, because in case that, like right now, the ground is the one who's in control of it, but if they needed it, then they're able to know that they could, control the rack.
And so where do you see this going? What's the next step and areas we need to look at for future communication delays?
Well, we're looking at we're collaborating between Marshall, JSC, and Ames, academia, and other commercial businesses. We're looking at trying to develop different operations concepts of trying to do demonstrations on board the ISS, things that will help the crew for deep space missions not to have to rely on the ground controllers as they do today.
So we've already had a few runs. So far, so good, right?
Yes, they've all been successful, and we've been very pleased with the success that we've had. And we've got another run that will occur next week.
All right, good luck with that. A lot of work ahead, Angie. Thank you so much for joining us. That will do it for us from the Payload Operations Integration Center. Now back to you at Mission Control in Houston.